Hello. This video I'll be going over example 13.3 in order to complete the requirement for Professor Meyer's class. Before actually diving into the example itself, I wanted to go over a couple notes that are pretty much required to complete the problem. We're going to need the equation from Newton's law of gravitation. We also need to understand superposition of forces, which is just the fact that gravitational forces can be combined vectorially in order to find the total gravitational force. So what this example is asking for is to find the total gravitational force exerted on a small star by two larger ones. Step one would be to find the individual forces each larger star is exerting on the smaller star. So if we go to find the first force between what I called M1 and O, we just use the equation from Newton's law of gravitation and input all of our different variables in there, which ends up equaling 1.33 times 10 to the 26th newtons. For the second force, between M2 and O, it's pretty much the same thing. The only difference is that the distance we have to calculate using Pythagorean theorem, and after all the calculations, it should come out to 6.67 times 10 to the 25th newtons. Now we use our knowledge of vectors to find each component of our F1 and F2 vectors. Since F1 is directly to the right of O, it's not going to have a y component. So the x component will just be the same value it already has. For F2's x and y component, we just use cosine and sine respectively and multiply it by the original force. That way we can get the correct components. So we add these two pairs of components that we found. That way we can get the x and y components of our resulting vector. Now we use the Pythagorean theorem to calculate the magnitude of our resultant vector. This result is the total gravitational force exerted on the small star by the two larger ones. Now to find the angle this force makes with the horizontal, we just use arctangent of the y component over the x component of our force, and it should equal 14.6 degrees. And that's how you find the total gravitational force exerted on something small by two larger things.